Alright, so we are going to now discuss the derivatives of exponential and logarithmic functions, two of our favorite functions from before. And we are looking at the graph 2 to the x, right? In general, this is a to the x, and a is set to be 2. And so what we notice here is that it's an increasing function, right? So its derivative should always be positive. And it seems like the tangent slopes are a lot bigger on the right than they are on the left, right? Things are really, really shallow on the left, and so our tangent slopes should go towards 0 on the left, and they should get really, really big on the right. So the tangent slopes get really big on the right. And so what you might notice if you follow the black dotted line is that the derivative of the exponential function should also be an exponential function. It has essentially the same shape. If I change from 2 to 3 or something like that, right, we get some similar type of behaviors where it's going up on the right, it's coming down on the left, up on the right in the same way. And so the derivative of an exponential function is an exponential function. And so we go ahead and sketch out, set this to be 4 even maybe, what it is, we get that value. Now as far as which exponential function, there's a more detailed discussion of this uh, in the text or in the handouts that I made, but one of the particular exponential functions is e to the x. And e is this very special number where if I raise it to to x as an exponential, its derivative is actually itself. So you can see here the sketch of the red line and the blue dots completely overlap. They're exactly the same function. And if I were to sketch a separate e to the x, it would be the identical function here, right? Now, in general, if I let uh, a be some other value, we do look at the blue dotted, not dashed line, as an exponential function, the derivative of an exponential function, another exponential function, but it's not necessarily the same one. See, this one here is a little bit below R2, and that's because A is less than E. If I go over, like 4 is greater than E, then the derivative goes above it. Now the exact shape of this function is a to the x natural log of a. And we can see that purple line go directly above the blue dotted line. And that's going to be true no matter how I adjust a. And we can go ahead and try to do some similar analysis. Let me kill this off and turn this off for log base a of x. So let me set my a to be something kind of normal. So this is log base 2 of x, and we can see that, right? It does get bigger and bigger over time, but very slowly. And so the slopes get closer and closer to being 0, right? And so we're looking for a function that does something like that. And it turns out, first of all, in the special case of e, right? Let me zoom way in here. Then that's what its derivative looks like, and we can watch those tangent slopes follow along. And this just happens to be the line y equals 1 over x. Right? That blue line and those black dots coincide perfectly, and that gives you that shape. And let's say again, let's suppose a is some arbitrary base, then it should be is 1 over x natural log of a. And now, again, if I adjust what a is, both the derivative and this black y graph are changing exactly the same way, and that's because they are exactly the same. And the handout gives you a more detailed explanation of why that is.